I'm Joanne Larson. I work at Seagate in a design center. I have two drives here just to illustrate a couple of form factors that we design. This is an example of a 2.5-inch drive, as we call it, which would be used, for example, in a notebook computer. This is what we call a 3.5-inch form factor. A hard disk drive is so named because the heart of the matter is where the data is stored, which is on these disks, and the data is stored magnetically as ones and zeros or as magnetic bits that are oriented north or south. It is read or written, as we say, by very small transducers on heads. So this little roughly triangular shaped feature can be thought of as the size of a bit. When we write, and this is the write pole, the flux is essentially focused through that pole. The corresponding area on the media below it is magnetized. The head is out flying on a suspension at the end of an arm. This is an arm, which is part of what we call the head stack assembly. The arms move back and forth across the stroke and read the various tracks that are laid out on the disk. These tracks are so narrow that we fit about 300,000 of them in an inch of radius. The arms, the HSA pivot is actuated in this case, and I think this is kind of fun, magnetically. As we know, electricity and magnetism exist together, and when a current is run through a wire, there is a corresponding orthogonal magnetic field. So how we are using that here is that there is a coil, which is, it's actually hidden under this magnet. Under this plate there's a magnet. And below the magnet is a coil. The driving force of the current, or conversely the magnetism, forces the back end of the coil to move in one direction or the other. Right here we see the motor that spins the media. When the drive is powered off, the heads are resting on this ramp. The arm swings off so that the heads are preserved and they're not touching the media or anything. If I want to write or I want to read, in other words, if I want to record a picture or if I want to bring out a picture file, the arms swing out over the disk and the heads are flying over the tracks, as we call them. So it goes to a very specific radius and the drive will be given an address to go. Let's pretend that was the radius, that was the track that contains the picture or part of the picture. That is the file that we said, please show me this picture. The data is recorded in magnetic domains that are very small surface area on the disk. The transducer on the head senses for that domain the direction of the magnetism and whether it is a 1 or a 0, and that's a bit. The head takes all of those bits and transmits that electrically up into the channel. It is reconstructed back into a data form that we recognize as an image. What we are looking at right now is the surface on the recording head that's facing the media surface. So the disk is spinning under the head, and there's an airflow or shear between this air-bearing surface and the media surface. These darker areas are in relief outward, and the medium range is actually inward. And these surfaces in relief are functioning in the way that we would think of wings or the features on a jet that control the flow of air. Everything that we can see in this view is only to support what we call the transducer out at what is the trailing edge of the head, and it's where the magnetic flux is read and written, or where we control the flux back and forth between the head and the disc. This is a very close view of the transducer, and at the top, it's not necessarily possible to see here, but we'll show a picture in a minute, is what we call the right pole. It's a very tiny dot in the middle of a triangle at that location, and that's where the pole that writes is visible. Down in the middle of this stripe is what we call the read element, and that is the location where the magnetic signal is sensed for the read function. So our magnification right now is 85,000, and our micron bar is 200 nanometers. When you think about it and you think about the size of molecules, we realize that some of these layers that we're looking at are roughly a few atoms or a few molecules thick. That is particularly true of the read element, and it's just a tiny dot or sliver when we look at it, even at 100,000x, and it has several layers which, again, are atoms thick at most. Very simple in concept, and an amazing amount of technology.